Find the inverse of the matrix and verifying that the inverse matrix times A equals A times A inverse equals the identity matrix, where the matrix A is given 2 by 2, dimension with the first row 7, 4, the second row 3, 2. There are two ways to do this for a 2 by 2 matrix. The first way is to simply use the formula. The matrix A inverse is 1 over AD minus BC times the matrix D negative B negative C A, where A is the entry 1, 1, B is the entry 1, 2, and so on. In this case, A, B, C, D are the real numbers. The quantity AD minus BC is therefore 7 times 2 minus 4 times 3, and this is 14 minus 12, which is 2. This has a name. This quantity for a 2 by 2 matrix is called the determinant. And if the determinant is non-zero, in this case it is 2, then the matrix A 2 by 2 matrix is invertible, meaning it has an inverse. We see that it makes sense here because if the determinant is 0, then we would divide it by 0, which would make this expression undefined. So we can always use this formula if the determinant is not 0, and the determinant is AD minus BC in this case. Once we found the determinant, we obtain the inverse matrix for a 2 by 2 matrix only. These shortcuts only work for the 2 by 2 matrix. The inverse is 1 over AD minus BC is 2 times the matrix D, which is 2, negative B, negative 4, and then the second row, negative C, is now negative 3, and A is 7. But we want a matrix, not a scalar multiple of the matrix, so we would distribute the 1/2. 1/2 times 2 is 1. 1/2 times negative 4 is negative 2. 1/2 times negative 3 is negative 3 over 2. And 1/2 times 7 is 7 over 2. This is the inverse of the matrix A. We still need to verify this. To make sure that this is indeed the inverse of the matrix A, we take A times A inverse, or A inverse times A, where A is 7, 4, 3, 2, 2 row, 2 columns, and the matrix A inverse is 1, negative 2 as the first row, negative 3 over 2, 7 over 2 for the second row. We multiply the two matrices using the inner product. The first row times the first column is 7 times 1 plus 4 times negative 3 over 2. And then the first row times the second column, 7 times negative 2 plus 4 times 7 over 2. And then to get the entry in the second row and the first column, we will take the second row in the first matrix, multiply the first row in the second column as an inner product. So this is 3 times 1 plus 2 times negative 3 over 2. And lastly, 3 times negative 2 plus 2 times 7 over 2. Simplifying this, we have 7 plus 4 times negative 3 over 2 is 2 times negative 3, or negative 6. 7 times negative 2 is negative 14, plus 4 over 2 is 2. 2 times 7 is positive 14. 3 times 1 is 3. 2 divided by 2 is 1. 1 times negative 3 is negative 3. 3 times negative 2 is negative 6, plus 2 over 2 canceled out. We end up with 7. 7 plus negative 6 is 1. Negative 14 plus 14 is 0. 3 plus negative 3 is 0. And negative 6 plus 7 is 1. So yes, this is the identity matrix 2 by 2. And we verified that the matrix that we found is indeed the inverse of the given matrix. The shortcut that we use only works on a 2 by 2 matrix. But what happens if we do not know this shortcut? If we don't know the shortcut, we would need to set up the matrix A, which is 7, 4, 3, 2, and we attach the identity matrix next to it, which is 1, 0, 0, 1 of the same dimension. And then we perform row operations to turn the first half of the matrix into the identity matrix. Whatever we do to this first half, we would need to do the same thing to the second half. And we end up with another matrix for the second half once the first half is the identity matrix. And that new matrix is the inverse of the given matrix.